Very good evening to everyone. Hi, this is Ashwini Kumar Gupta from Sultanpur. Well, I hope that you all are fine and enjoying a lot along with your studies. Well, I'm here for, teaching for physics. And today we will discuss about one of the most important topic of physics that is called Kirchhoff voltage law that relates with electrostatic. So, but before we start this, topic, I would like to introduce about my qualification as well as my experience, right? Well, I have more than 10 years of teaching experience in reputed engineering institute, as well as I have been working for last not six, basically, it's a 4 year uh, in our intermediate school that is based on CBSE pattern. Up to 12 I'm teaching mathematics and science, right? Physics especially. Along with that, I have joined byjus as a part-time online tutor academic specialist in the month of March to the 2022 till now. So let's start our demo topic for today, that is Kirchhoff's voltage law. So I'm just going to share my screen. First of all, we will discuss about the concept of KVL, and then we will solve this one by taking some circuits and some, datas so that we can have a better understanding about this topic. Okay. So here I'm presenting my screen and I hope that this is visible to you all. First of all, let's try to understand about the concept of Kirchhoff voltage law. Okay. So basically, there are two laws that are very important for electrostatics and this current electricity that are known as the first one, Kirchhoff's current law, or generally in general, what we say them, this is called as KCL. And the second one, that is Kirchhoff's voltage law, that is KVL. Okay. So I'm not going in so much detail in this video, but I would like to tell you about the KCL, that the KCL is used at the junctions, or we can say simply nodes, right? Basically, KCL says that the algebraic sum of all the currents at a node is always equal to zero. That is, sigma I is equal to zero. This is a simple mathematical description of the KCL, that is Kirchhoff's current law. Okay. For example, we are having certain, paths. Suppose like this one. This is an incoming current I1. This is an incoming current, suppose I2. This is an outgoing current I3. This is an outgoing current, suppose I4. And this is an outgoing current, suppose I5. So it says that total incoming current is equal to total outgoing current. Okay. This is basic concept of Kirchhoff current law. So we are not going to discuss in detail because of the primary topic that we are going to discuss for today is that is Kirchhoff's voltage. Okay. So as we have discussed that KCL is applied on a node or a junction. Node or junction, that means a point where the different branches of the circuits are, interconnecting each other. Okay. Similarly, we apply the Kirchhoff voltage law or KVL in loop. Okay. Or we can say in mesh. Okay. Either we can use the term loop or we can use the term mesh. So here we use the Kirchhoff voltage law. Basically, it's based upon the conservation of energy law that we have learned in a previous classes. So what is basically Kirchhoff's voltage law? So for this, I would like to share again another thing that is called the images. Let me share the screen first. Okay, this is a circuit what I'm having here to explain about the concept of, you know, that is KVL. So according to the Kirchhoff voltage law, what it says that whenever we apply this kind of law in a closed loop, loop means a circuit arrangement that consists of various electrical components along with the source. So it says that the algebraic sum of the all the voltages in a loop is always zero, or we can say the algebraic sum of all the sources is equal to the all the energy that is being utilized across the resistances. Okay, the definition may be differ from book to book, but the basic concept is this: the amount of energy that is being supplied in the electrical network, it will be consumed by the resistances or the resistors, whatever we have applied there, whatever we have utilized in that particular circuit. Okay, so this is basically KVL, Kirchhoff voltage law. Here, there are basically some rules to apply the KVL. Okay, what are the different rules? Let us try to understand about this one. Basically, the first thing that we should know about in KVL, that is called sign convention. For the better understanding of KVL, we should know first that is a sign convention. There are some rules through which we can apply the sign, okay, behind, in front of the magnitude of the given values. So sign conventions are, specified for voltages as well as current separate. Like an example, for potential, if I say, for potential, if I say, then the sign convention will be considered in the terminal of battery. Like an example, here we have this E1 source. So whenever we are moving in the source from minus to plus, okay, whenever we are moving from negative terminal to the positive terminal, suppose this is E1. So in this case, whenever we are moving from negative to positive, in this case, the E1 will be taken as positive. A1 will be positive. Okay. In some books, it may be that they can, they could have taken E1 as negative, but don't worry about this. There are two types of sign convention. Okay. You can follow either of them. Now, second one is, suppose we are moving from plus to minus during the circuit like this one. Okay, maybe it happens that the current is moving from positive terminal to the negative terminal. So in that case, whenever we are moving from plus to minus, we will consider even as negative. Please remember the thing that what I am saying to you. We are moving from minus terminal to plus terminal, that is negative terminal to positive terminal, then the voltage will be considered as a positive. And whenever we are moving from plus to minus, it will be considered as negative. Okay. And the second one, that is, if we are working for, resistors, for resistors, the voltage drops. Okay. We will consider about the voltage drop. So for an example, suppose this is a resistance we are having. So if the direction of current is like this one and we are moving in the loop in the same direction, let us try to understand in which direction we are moving. Suppose this direction and the direction of current both are same. That can say direction of current and direction of movement both are same. So in this case, if both are same, in this case, we will consider, suppose this is resistance R, so the drop will be considered as minus I into R. It will be negative. Okay, the drop of the voltage drop from Ohm's law, that is IR, so it will be taken as negative, right? Similarly, suppose we have the network here, okay, and now We are moving in the same direction, but now the current is in opposite direction. Okay, current in opposite direction, and we are moving to the just opposite to the flow of current. In that case, the potential drop, or we can say the voltage drop, it will be taken as positive. Okay, so these are the few points that you should remember. The first thing, whenever we are moving from negative terminal to the positive terminal, then the voltage will be considered as positive. And whenever we are moving from plus terminal to minus terminal, it will be considered as negative. Okay, and again, if we are moving in the same direction, in the direction in which the current is flowing, so the potential drop will be taken as negative, minus IR. And if we are moving opposite to the direction of current, then the potential difference will be taken as positive. These four things, if you remember, then every kind of electrical network, electrical circuit, you can solve very easily by the application of KVL. It's so simple. Okay. So by recalling these concepts, let us try to apply that KVL in the given circuit. Okay. So I am just erasing my all the written work here so that I have the circuit, right? Now, this is the basic circuit what we are having, and let us try to understand. First of all, we will draw a simple assumption of loop. Like suppose we are moving in the clockwise direction. So we will apply KVL in A, B, C, D. Loop A, B, C, D. And it is a very, very simple process. Just try to imagine. Just imagine yourself that you are lying at a point and you are walking. This is a simple thing. Only the thing that you can understand in a very better way, that is just imagine yourself at A. Suppose I'm just going to write the equation for KVL from for the loop ABCD, and we are starting this from point A. So just imagine that you are at point A. Okay, so whenever we have started to moving from A to B, we have to move from A to B. So once we will move from A to B, what we observed? We observed there is a resistance R2. So when we have observed this R2, and since we are moving in the same direction as of current, so here the potential drop will be considered as negative. So it will be minus I2 into R2. Okay, as the circuit has shown this one. Okay, again we have reached to the point B. Again we will move from B to C. So there are two particular items are kept here, two components are kept, that is R3 resistance and the voltage source E2. So whenever we are moving from A to B and then B to C, let us try to understand. We are moving from B to C, but the current that is being developed in opposite direction of, so here our motion and the motion of direction are in opposite direction. So in this case, it will be considered as plus I3 into R3. Okay. Okay. Again, let's try here plus minus. We are moving from plus to minus in the voltage. So it will be considered as minus E2. So where we have reached? We have reached to point C. Okay. Now move ahead from point C to D. So here if we see, again the current is moving from D to C, but we are moving from C to D. So opposite in direction, that means we can write here I4 into R4. This is the potential. Now we have achieved to point D, but since we have started our journey from point A, that is why we have to reach at point A again. So whenever we are moving from D to A, so let's see, here we have phase up potential from minus to plus. So for the negative to positive, it will be considered as plus E1. Okay. Now the current is in same direction where we are moving. So it will be minus I1 R1, and hence we are here at point A again. So the loop has been done. It will be equal to 0. Okay. So we can write here, if we want to solve, we can write simply E1 minus E2, E1, sorry, minus E2 is equal to I2 R2 plus I1 R1 minus I3 R3 minus I4 R4. Right. So this is a simple way in which we can write the Kirchhoff voltage law in the given circuit. So in general, what we can say? In general, we can say for KVL that is sigma V is equal to sigma IR. The total amount of voltage or the EMF, electromagnetic force, given in a circuit is equal to the total drop across the different branches of resistors. Here we can put here N is equal to 1. Okay, J, suppose J is equal to 1. So Vn, and J is equal to 1 to N, that is Ij and Rj. This is N. Okay. So this is the way in which we can understand about Kirchhoff voltage law. Okay. So I hope that this thing you have understood and you have enjoyed the session. Okay. It was a great session with you all. Thank you very much.